So we have a perfectionist somewhere. And
What?
a perfectionist, according to the poll.
Oh, right.
So if you haven't seen the poll questions, it's or question, it's do you clean your mineral specimens? And the options are always, I'm a perfectionist, and we've got one.
Oh.
Most.
Where is that? I haven't seen that.
So down the bottom, you know, where you have the chat. Hang on,
Yeah.
just muting Jacques for a sec.
Yes.
We have chat and share screen.
Polls.
There's a polls as well.
I'm not. Yeah, that one.
So that's pretty good. So we've got nobody that's clicked on never. So everybody does some degree of cleaning of their minerals at some point in time, which is good. And it looks like the winner is most of the time. So the vast majority of people clean specimens most of the time. That's quite interesting. I don't know who if the perfectionist wants to put up their hand and admits. Jim.
Jim.
Yeah, I always run them through the ultrasonic, no matter what.
Yeah.
Unless they're water soluble,
Yeah.
then you have to do it in isopropyl alcohol.
Yeah.
But I always do some making sure that the loose stuff is off, and there's not something that's contaminated the specimen from somebody having it in a box with others.
I opened an 8 carton of stuff the other day from my favorite little mine, Killam, and all the bits and pieces in it, must have been maybe 60 or 70 pieces, had these very fine whiskers on them, and you can't see underneath them what's growing there. So I just dumped the whole lot into water, and that washed all of it off. So that was a water soluble growth that had come on it. So it's obviously gypsum or some sort of iron sulfate, which is just dissolved in water, and that was lovely to be able to see it afterwards, without having to get the water gun out.
So you just destroyed possibly the only example that exists?
No, I didn't.
Of a
No,
new
I didn't. I didn't, Frank. I know what's on the stuff. I didn't do that.
All right.
Martin, what's common from that locality?
It's an old tin mine. So you got cassiterite, but there's about 4, 5, 6 different sulfides and oxide veins running through it, and they're all mixed up together. So you got a real mix up of stuff.
Those white hairy things could be melanterite or something like that.
Yeah, that was. I think that was that, because you get it. The actual mine itself, when you go into the mine and look at the very far end of it, where the dry finishes, it's just complete walls of gypsum.
Well, gypsum normally won't wash off in the water.
No, but this other stuff it grows very, very quickly, and I quite often will get a specimen out of its box, have a look at it. I've got these white whiskers all over it. And I've tried to blow them off with the blower, and it doesn't even touch them. So I think the water's the easiest option, just to dip it in water, and that was gone.
The only example of tin sulfate you've just destroyed.
Yeah, probably.
You could have had a new mineral named after you.
We got plenty of those waiting to be done.
Mm-hmm.
Getting them tested is the problem.
It'd probably be a bit hard to pronounce Martin Stolworthyite. It's sort of roll off
too
the
long,
tongue.
too long, too
Doesn't
long.
roll off the tongue very well.
No.
You wouldn't get it on the label.
Yeah.
All right. We've got quite a decent number of people that I think have joined now, 21 in total. That's pretty good. So this was always going to be quite a difficult one to sort of manage, I think. So what I've done is I've come up with a couple of headings, things I think that would be good to discuss, and it fits in with a little bit with some of the comments for Doug. Unfortunately, Doug can't join us. But basically, the first one is, what do you consider needs cleaning or removing? And Martin's example is one of those things, obviously. But there's things like dust and dirt, hairs, lint, unwanted material, so things like iron stains, other minerals. So, you know, some people clean off calcite or manganese oxides and that sort of thing. Fingerprints. I remember being in Tucson one year, and there was a tourmaline and quartz specimen, and the quartz was sort of that sort of size, and it had a fingerprint or a thumbprint mark right in the middle, and it sort of reflected in the light. It was very obvious. Mineral tack, you know, you get a specimen where the tack's gone a bit oily or whatever. And then
Does anybody know how to really get that stuff off?
well, we'll come to that.
Yeah.
I don't have a magic wand on that one at the moment either, but yeah, there's probably a few ideas that might come out. So the second part of it then is, what do you use? So that could be things like, I know somebody's actually done this, dishwasher. I know I'd be dead if I tried to do that. Just warm soapy water, toothbrush, ultrasonic, pressure gun or needle gun as in the chat. Acids of various types, iron out, sandblaster, canned air, just your breath, acetone, alcohol. So there's a whole heap of things in that space. And then the third thing, and I think Julian touched on this in the chat as well, is precautions. So obviously your own personal health and the health of other people around you. You've got to look at the specimen fragility or reactions, so solubility is an example. And I thought if we cover each of those three areas in a discussion format, that, you know, we might get some good conversations going. So if we go back to the first one, what do you consider needs cleaning or removing? Was there anything on top of that list, or would you like me to reread it? Or
I'd just comment that if you don't know what's on your specimen, you don't know how to clean it.
well,
Agreed.
this is true. This is true.
So that's the first step, is identify what it is that you want to remove.
In the case of Martin's stuff, it was white hair.
Well, I more or less know what I'm going to be looking for on most of the stuff I'm looking at. So if it's got muck on it, I wash it off.
Yeah.
My stuff's nearly all self-collected, so it doesn't come to me pre-washed by a dealer or tarted up by a dealer. So if I've collected it and I know what I should find on it, I look at it first and see, then I'll give it a wash afterwards.
So one problem that I have with that, Martin, is particularly when you're dealing with micros, is I do tend to find stuff when I go through the photography process that I haven't actually picked up under the microscope. That could potentially be something you might lose. So you've got to be a little bit careful with that too.
Oh yeah, yeah.
Especially
I must admit,
flavors,
the first thing that
especially-
I do is blast it with the air thing rather than wash it. That with well, the first thing I would do is actually look at it under the scope and then decide what it needed. You know, whether it needed nothing, whether it needed just a blow, whether it needed a wash.
Yeah.
But yeah, it's definitely cautious steps, the least aggressive steps first.
Yeah.
But I've actually looked at specimens where I've looked at them with a loop and under a scope, and they look perfectly clean. And I take a picture of it and I think, damn, where the heck did that piece of cotton come from?
So ultraviolet photography will pick up any of those things for you. So.
Absolutely. A UV torch is really good for picking up like lint and fur and stuff that's invisible. Shows up very nicely. And I have one of these for getting rid of the first set of dust and crap, all the loose stuff.
Yeah.
It's very useful.
So nothing else to add to that list. So dust and dirt, hairs and lint, unwanted materials such as iron stains, other minerals, fingerprints, tack. So reasonable sort of list to
or glue.
Glue, tack
Glue is
slash
one.
glue.
Yeah.
Tack, that comes down to that. Does anybody have any ideas how to really get off that old blue stuff that's gotten really hard?
So There are some orange oil based cleaning compounds, either the hand glue, the hand, like the degreasing garage cleaner that work quite well. And there's a product I found called, well, the commercial brand name is G-Solve, but it's basically a cleaning solvent for removing chewing gum. And it works brilliantly on any plastics and glues. If it doesn't dissolve them, it softens them right up. It's quite slow acting, so I tend to soak overnight. The only downside with that is because it's an oil-based thing, everything tends to get a little bit greasy afterwards. It tends to stick around. So I tend to soak it in alcohol afterwards and then wash it.
Yeah.
I use alcohol on some of my bits and pieces to get them off, and that does remove some of it.
Yeah, acetone's good as well. Any of those organic solvents will do a reasonable job. Some of them will poison you faster than others.
I think you do exactly the same thing I do, Paul. We have something in the States called Goo Gone. That's a citrus-based cleaner made for removing gum and all kinds of sticky stuff, and it works really well. I've used it with all sorts of minerals, and yeah, it does work a little slow. So if and if it doesn't get into like some of the really nasty crevices and stuff, I'll just take a little toothpick and just work at it too. Just carefully pick at it, and it will remove the blue tack. And then, like you do, you just kind of soak it in a little bit of alcohol afterwards.
Yes.
Just keeping an eye on it. I've had great results with that.
Yeah. We've got a similar product here, Paul, called sticky stuff remover.
Yeah, they're probably very similar materials, all of them. So
yeah.
I think I've found certainly with older specimens, Jim, I think you're lucky if you've got tack that's actually gone hard. It's the stuff that doesn't go hard but goes really oily and sticky that can be very difficult to get out, particularly on micros, because you're dealing with such small crystals and they're a lot more fragile than maybe bigger stuff.
If you go wandering through the paint aisle for paint strippers and the like, a lot of those solvents are quite aggressive and very effective, as long as you avoid any that have got caustic in them and go for the organic ones. A lot of those will do a very, very good job of removing everything organic from your specimen. So that's also an option. Again, they'll poison you at various rates. So
even lichen, Paul?
Probably not.
Little butane torch or something.
Yeah,
a little bit of heat treatment might work. There are some in microbiology. There are some organic enzymes that are quite good at digesting cells, but I don't think they're going to work on cellulose or lignans very well. And I am not a biologist, and I don't know if it's subtle. That's probably not my
I've got a heat gun that I bought off of Amazon for 20 bucks or so that I use on that gray tack that gets real. It gets hard, but it's still won't come off. If you put a little bit of heat on it, just be careful you're not putting it on something that's going to break.
Yeah.
It wouldn't heat fluorides up very high. But it will get that stuff softer that you can start to pick it off.
Yeah, and that's important if you can soften it up.
Yeah,
then like I said, it's
you pick it off by using a fresh attack and just keep picking away at it. It off.
Yeah, you can use toothpicks. I have a pair of it claims they're brass tweezers, but they're a lot softer than brass tweezers. And I can go in and use that too. I also have a set of plastic tweezers that work really well too.
Yeah, toothpicks are great. Yeah, any of those wooden tools, they work really quite nicely on most things that are, as long as they're not acicular needles. The other thing that's worth noting is you don't need to go to a lot of these. Like there's probably a very small number of chemicals that will cover most bases. So metho and the citrus cleaners and maybe some acetone and water, and you've probably got all bases covered. The other thing you can do with metho, which is usually ethanol these days, not methanol, it's very good at displacing water. So if you've got a specimen that's got wet and you want to dry it out and get right into the crevices and put it in the ultrasonic bath with in fresh metho, zap it for 15 minutes or whatever your normal time is, and just let it dry, and the water will go away with the alcohol. So I use that on pyrite, for examples, to try and get as much water out of it as possible, because that's one of the things that will cause pyrite disease.
There's some spray cans of stuff that use in the electronic industry to dry things out, and that works fairly well too.
Yeah.
All right, some good discussion there. Let's have a look at. Unfortunately, we've lost Julian. He's got to go to the dentist, which is unfortunate. Jim Glenn's just put a note in that he uses an ultrasonic cleaner and has found that CLR works well with non-calcium minerals. And yeah, CLR obviously is not something you want to use with any calcium because it's designed to remove that. Looking at what people use, has anybody yet to use their dishwasher?
No.
Nobody else.
I wouldn't dare use the dishwasher.
No.
I do know people that have.
Yeah,
she wouldn't do it anyway.
Pencils.
My dishwasher wouldn't do it anyway. So
I know there was a Mindat chat or discussion around it at one stage.
I don't own a dishwasher, so that's not a thing with me.
All right, so one of the things that I think is fairly important is if you've got something that you really don't want to destroy unless it's absolutely necessary. If you've got a second piece of lesser quality material, try things out on that first.
Yeah.
And I would obviously, I think I'd start just with sort of dunking it into a container of warm soapy water upside down and swishing it around a couple of times. But after that, what else do you use? So how many people here use an ultrasonic as an example? Paul, I know you do. I do occasionally.
Yeah, I do.
Occasionally.
Yeah.
I've got a couple of them. I don't find them that good, actually.
Yeah, it depends what you get. If you get the little jewelry cleaner ones, so
that doesn't touch muck at all. I paid over £200 and bought a really big one, big powerful one. That still doesn't do the job properly. It still leaves a residue of muck. Nothing beats the water gun.
Yeah, and Jacques, were you holding up paintbrushes before?
What do you say? Yeah, the brushes, yes, of course.
Yeah.
Yeah.
I only use it for micromounts, of course.
Yeah.
And when I have to make photos, it must be clean. So I had all kind of brushes here, very small, tiny dentist tools, of course.
Yeah.
I have a pair of precision.
And I use my ultrasonic, and most of the time everything is perfect. Only problem I have is, of course, with those pussy stuff like olivenite or artonite or something like that. That's not possible to.
Yeah, I
think we've all got those collections of brushes and dental tools.
Yeah, but most people don't need. You need time to make a good photo. Most people I watch are too hasty. They think, oh, I have only 5 minutes. I use sometimes 1 hour for making a photo. And I take time to clean up my specimens.
One problem that I have with that, Jacques, is that static sometimes introduces more bits of crap than you actually remove. Any ways around that?
Cats.
Yeah, well, cats. Then you introduce cat hairs.
You know
Don't
this?
live in a dry climate.
Well, is that an
One
anti-static
of the
spray?
biggest problems I've got is
Anti-dust spray, yeah.
Anti-dust spray. Okay.
specimens that are in
Yeah.
boxes for a long while. When you get them out again, they've got all these little tiny microbial whiskers all over them.
Yeah.
And the specimen is clean, but when I take a photograph of it, well, all those spider webs everywhere, and it's a real problem. Then you got to either reclean them again or put up with it.
Perhaps they are spiders, Martin.
I keep a lot of my specimens in air cartons because they're very useful to take on field trips for that size specimen. The fibers are dyed and the dye is fluorescent. So I get on the specimens, these all need to be cleaned before I photograph them, especially if I'm going to be using UV, because I get these lovely bright yellow spots, orange spots all over my specimen. Yeah, not a new mineral.
I won't even say how difficult it is to try to keep nice specimens in a hot tropical climate.
Mm.
Yeah, I imagine. Yeah.
Yeah. Must be awful.
I feel for you, Paul. We have probably both ends of the spectrum. So I've been living here about 10 years. We've had -7 degrees through to 48. So not on the same day, but that's pretty extreme range. Yeah, Melbourne's the same day. All right.
Especially which are probably difficult to clean are the very small spiky ones like Naturalite, which are very fine needles. So
Yeah.
I don't bother at all. I just take it as this.
You take a photo.
Yeah.
So that's where what I do with my photography is, if there's always going to be something that I've missed in terms of specks of dust or hairs or whatever, and I actually edit them out. It doesn't take long to do. So rather than trying to go through the process again.
Yeah, sometimes that's all you can do.
Yeah.
Yeah.
Can I show a photo I made 2 weeks ago?
Yeah, sure.
It's I have to do it. Let me see.
Yep. So just go into share screen.
Share screen, okay. And then, oh yeah, well, what? Files.
So then you select what you want to share.
You need to select your picture first.
First, I'm going to try. You go on with the discussion. It's too difficult. Okay.
I'm just going to put a link in the chat of the chemistry solubility rules, because this is one of the things I find really useful.
I got it. You can see this?
Yes.
Oh, yeah.
Photo of a very
yes.
fine conolite with broken tides. And you see all these dust particles. I can't remove them. There are it's mine. It's stuff. It's coming from the mine, and it's completely covered with it. And I have to leave it like it is.
So so that's one that I would go through and remove each of those, or at least the most unsightly ones after. And it's actually quite easy to do.
Yeah, I personally wouldn't bother because it's too much.
They are there. Okay.
You're gonna risk damaging that specimen if you try to go in there.
Oh yeah, you're not going to physically remove it. Steve's talking about digitally removing it.
Digitally, right? Yeah.
Exactly what I meant. A specimen like that is impossible to clean up.
Yeah. So I mean, that's a true representation of the specimen. That's okay. What you need to do is go back to the mine and get another specimen just like it. It's not got this.
Okay, next time.
Excellent. All right, Paul. So you were saying you've got a solubility.
Yeah. So
matrix?
in chemistry, there's some arbitrary rules that help you decide whether a compound is going to be soluble in water or not. I've had a couple of situations where I've been removing calcium carbonate with acids, and I've ended up with gunk all over the surface of the specimen, and then I've realized I've used an acid that forms a calcium salt.
Yes.
Or I've got a bit of soap in there and I've got calcium stearates coating everything. And some of those calcium compounds can be very stubborn to remove, which is much annoying.
That's a really good list, Paul.
Thank you.
Thank you for that. I'll just save that somewhere.
Yeah. One of the things about acids is the effect of the acid is purely down to how many hydroxyl ions there are, hydronium ions, how much acid there is in the acid, not the chemistry of the acid itself. There's stronger acids just dissociate more. They have more acid per volume per mass than otherwise. But this rules about what forms what. That determines whether you get precipitate or not.
And that's the list up for everybody that wants to have a quick look at it at the moment. That's a very, very good.
So hydrochloric acid is really good for everything except silver.
Yep.
And the halides.
Yep.
Can we
Cool.
print that list off or?
Oh yeah,
that's just a web page.
It's just
So-
on the internet.
Oh, right, yeah.
So in the chat, Val, Paul's put a link,
Yeah.
which is this link up the top.
I
here.
saw the link, yeah.
Yep.
That site is a whole bunch of free texts, technical texts, open source.
And you can click on the little red square and it'll save as a PDF, download as a
Yep.
PDF.
That one there. Oh, full book.
Oh yeah. Done.
So there's probably more in there than you really want to know. But
Yeah.
Oh look, and there's a YouTube link as well. I hadn't noticed that.
So yeah, very good. Actually, talking about YouTube, there is one particular guy that does YouTube videos on elements, and some of the stuff that he has in there is pretty good too, in terms of what reacts with what. So
The periodic videos link.
well, yeah, one of those ones.
Yeah.
I'm not sure which one, but yeah.
There's quite a few of those that are. I mean, it's not just. So that started as an outreach for that university, and it's just grown and grown and grown, and now they cover all sorts of physics and chemistry subjects. Quite fascinating. I'll find the link and I'll put it in.
Excellent. All right. We touched a little bit on acids in that conversation as well, or not just acids, but anything that causes a chemical reaction. Who uses anything sort of a bit strong? Obviously, water is an acid, but it's a very, very weak one. Who uses anything else, like hydrochloric or worse?
Use diluted hydrochloric acid. So.
Yeah, the stuff that you can buy from the
Muriatic.
Yeah.
I used it once 40 odd years ago on fluorite from Hilton Mine to clean the I collected it and when I washed it in hydrochloric acid, and it's kept it beautifully clean to this day. No crust, nothing at all on it.
So I know I've actually
Good, but you're better off using phosphorate for the fluorite.
Phosphoric, yeah.
On it.
I know with the HCl stuff, I've tended to use it more for removing calcite than cleaning as such. And what I found was that, and I did it outside, I'd have two like ice cream containers, one with very dilute acid in it and the other one with bicarb mix. So that specimen, as soon as I'd gone as far as I wanted to go, pop it into the other one and stop the reaction.
So I was just going to say, vinegar is my go-to most of the time. It's very slow. It's very mild, and it works very effectively on calcium carbonate and doesn't tend to affect other carbonates too strongly. So recently I etched some siderite out of calcite, and that worked quite well until I ran out of vinegar and did some dilute hydrochloric acid, and I didn't get the balance quite right, and I started. I got a lovely brown solution instead of the clear solution that I was expecting.
So do you use a white vinegar or a brown vinegar?
I use just the cheapest goddamn vinegar you can buy in the shop.
Yeah, at 65. I was about 65p in Tesco's for half a litre.
I don't think malt vinegar works on it. I've tried malt vinegar.
Well, it probably smells nicer.
Better on your chips, Jane.
You can put on your chips afterwards as well.
I
you
was
see.
gonna say, yeah,
A
that'd
bonus.
be a waste of
Yeah.
good malt vinegar.
Oh, very
I
good.
know up in,
You
in,
can use the kettle descaler and that kind of stuff. I'll sometimes use that in a small dish on the
So
windowsill. And
that's a
that's quite
CLR.
slow acting, to be
Yeah,
fair.
that's a CLR, I think.
Yeah,
isn't it?
so that's sulfamic acid. So it's a modified sulfuric acid. It's got a benzene ring hanging off it. So it's a bit slower, a bit more, but it works quite well.
yeah, I've always found sulfamic to be kind of almost between vinegar and HCl, kind of in there.
Yeah,
It's
exactly.
we can get it here quite readily. All you gotta do is buy coffee pot cleaner.
Yep.
Here
Yeah,
in the
exactly.
States.
That's exactly what I use. Yeah.
Yeah.
Yep.
If I've got tourmalines or something with a little bit of Clevelandite on it or something, something there's maybe just a little bit mashed up around the edges, just pop it in a pot on the side and leave it for a few days, and it brings it up beautifully. So
Yeah, we figured out on native coppers. We a lot of people just use muriatic acid HCl on coppers, and which is fine if you just want to remove calcite and don't have anything nice. But if you got copper crystals, you do not want to use HCl on because it'll round off the edges.
Yes. So sulfamic on those.
Sulfamic or vinegar.
Awesome. I am going to do that because I have a copper specimen that I need to clean. I've been looking for a method.
A lot of people even I know a lot of the guys up there too. They'll even frown from using any sort of acid on it. What they'll do is they'll actually take their thumb, rub their nose, and then rub the copper.
Right.
To shine it up a little bit too.
Right.
And there you're not dealing with any. Well, I guess nothing. Like at least I hope your nose isn't acid. But it seems to do the job if you just want to keep really nice crystals without yeah, without burning the edges.
Actually, that's a good question. One of the things that I've been trying to work out is, having cleaned your copper crystals, how do you keep them from retarnishing, or how do you control the tarnish? Open-ended question. I still don't have a real answer.
Up in Michigan, one of the guys up there came up with this powder, and he called it Copper Bright. And what it is, it's I know it's made with chromic acid. I don't know the exact formula off the top of my head, but what it does, after you clean your copper, and they'll use, especially if they don't have any crystals, they'll use HCl, and then if they can't get the desired result, they'll actually dip it in nitric for a few seconds, and then really clean it off well. And then it's nice, bright, shiny, and then they'll dip it in this Copper Bright. And I've seen specimens dipped in that for, they'll dip it in for a couple of minutes, pull it out, and then rinse the hell out of it. And I've seen specimens cleaned that way that have remained shiny for 20 years.
Yeah.
So whatever it puts on it, I don't know the exact chemistry of it, but whatever it puts on it obviously does the trick.
Any clues as what the chemistry might be?
I have a bottle of it in of all places, my laundry room, up in a cabinet, and I'm pretty sure I know where it's at, and it's got a paper with it that does have the chemistry.
Cool.
So if you give me a couple seconds, I could grab it.
I'd be really interested. So yeah, at your leisure. You can always hit me up later.
So for me, having been at one stage of my life a coin collector, when I was a kid, some of the cleaning methods that were used by people on coins fits with minerals as far as I'm concerned. I would not clean copper to that extent. I would not want it to be bright and shiny and copper colored.
Well, that's the debate about copper.
The trick is to get the patina back.
Yeah,
Yes.
exactly.
So I have seen people who say you make it bright and then you let it oxidize again, and that's how you get the natural looking patina. I would prefer to remove as little as possible, and then stop the overgrowth coming back.
Yeah, I'm with you on that, Paul.
That would be ideal.
But it's delicate.
Yeah.
It's yeah.
Any-
There's a couple of things that I wouldn't mind trying. You can get, so if you're talking steel or aluminium, you get a stable stainless steel, you get a stable oxide coating on the outside. So if you can, and like phosphoric acid on steel is well known as a passivating agent because you get a iron phosphate coating that's more stable than the iron oxide. There are compounds of copper, like copper ammonium salts, that are more stable than the oxide and should form a nice stable film. But I don't know the chemistry and I don't have time to experiment. I want somebody else to invent it for me and then I'll steal their idea.
They use
Does anyone
Coca-Cola.
use Coca-Cola?
Yeah, I just mentioned that.
Yeah, so
Great minds think alike.
Coca-Cola is essentially sugar plus phosphoric acid.
Yeah.
Now, sugar is like sucrose, is a reducing sugar. If you mix sugar and copper salts, you will get metallic copper, especially if you heat it up in your sugar. It's a really neat way to get a copper coating on some stubborn on some things that's been used in the past.
Cool.
Phosphoric acid does look, when you look at those solubility rules, it does form calcium precipitates. So if you've got calcium on your thing, you probably want to avoid it. I suspect that the reason it's recommended for fluorite is more to do with the fluorite being susceptible to phosphoric acid than anything else.
Yeah.
And the calcium is probably locked away more in the fluorite.
Yeah, fluorite's kind of aggressive like that.
Yeah.
I was
So-
successful in finding what I was
About
looking for.
cleaning pyrite, anybody got any ideas for like these the pyrite suns that you get from Sparta in Illinois? I'd clean those up a little bit.
There was a discussion on Mindat. I'll dig it up and put it in on trying to treat pyrite disease. But basically, clean it, dehydrate it, seal it.
Yeah, but it's
Seal
the
it with
cleaning
what?
of it. You
Where do
clean
you
it with
seal it?
what?
So
I mean, I know with pyrite disease that, I mean, I'm a hairdresser, using perm solution, so thioglycolate, that kind of stuff actually works.
so it's not an auto-catalyzing reaction, so you're lucky in that sense. You can get some things that will just naturally decay, but the implication from what I've read is that it needs water to proceed. So the intent is you use whatever method you can to get into all the little crevices and remove the decay products that are water soluble or can absorb water. So ultrasonic bath with soap and water. Then dry it out, so ultrasonic bath with ethanol, and then impregnate it with something that is not obvious. So maybe a thinned glue that you then soak it in overnight or vacuum it in, and then you clean the surface off again. I'm thinking of using sodium silicate, but I don't know what's going to work, and it's going to vary from specimen to specimen. If you use something that is soluble in a solvent, then you can impregnate it to your heart's content and then use the solvent to remove it from the surface. So that's the sort of approach I'd be looking at taking. But part of the problem is you won't know if it's worked, even if the thing doesn't decay. Yeah, because you can have two specimens from the same location sitting right next to each other in the same conditions, and one will decay and the other one will be just fine.
Yeah.
So that's the problem I've got with that discussion is, how do you know that it's worked? Well, you don't until it doesn't.
Yeah.
Oh, that's a bacteria of some sort, isn't it?
There's bacterial actions implicated as well. Again, same approach. If you remove the water and you seal it, then the bacteria can't do squat. So, but I think it's the sealing part that is the critical step. If you prevent oxygen and reactants from getting in there, then it can only deal with what's already in the rock. And if you're lucky, it's not going to be, it's going to be at equilibrium and not try and chemically move energetically.
Yeah.
Paul's back.
Yeah, I just dropped the ingredients for that copper bright stuff I was talking about. Dropped it in chat.
Oh, cool. Cool.
Oh, copper bright.
All right. So the sodium oh, lovely.
Sodium
All
bisulfate,
right.
and sodium bifluoride,
Ah.
chromium trioxide.
All right.
No,
I am going to have to think about that.
Don't harm any crocolite crystals in the process, Paul.
I've got some spare. They'll be fine.
Yeah,
But,
stuff is basically, I mean, it basically just comes in a little, there we
Yeah.
go. Whoop.
Oh,
Yeah,
in front of you.
there we
Yeah.
go.
Little jar.
It's a little jar, it comes in, you mix it to a gallon of water. Distilled water though, not tap water.
Right.
And then, but it works great after you've initially cleaned it.
Cool.
Just one thing to add back on the pyrite discussion too, Paul, is that my understanding is some of the reaction actually causes the material to expand. So if you've got the reaction happening within the specimen, even if you seal it, you may not stop it because it's going to take more space.
Yeah,
and-
that's why
and
you
expand
want to.
out.
That's why you want to get as much of the potential reaction compounds out as possible before you seal it.
But your comment was quite true. You just don't know.
Yeah.
So
There are apparently some better techniques that museums use, but they tend to be both toxic and expensive. And I don't know what they are.
and then of course you could,
I've not found any rhyme or reason with pyrite when it rots or not. I've got 3 specimens in my cabinet in the other room. They're all collected on the same day, from the same location, along with 2 or 3 more smaller bits. Some have long rotted away, and the others still sit there pristine. That was over 45 years ago.
Were they from the
There's
beach, Martin?
no rhyme or reason for it.
Were they from the beach?
They're from Side Strand.
Yeah. Yeah, I've got some like that.
Yeah.
So I've got a whole tray. It's just piles of dust, black and yellow dust.
There's one location not too far from, it's near the Queen's place at Sandringham.
Yeah.
A little, and there's some sands have come down as part of the geology, and they form pyritized nodules sometimes. And when you bring them, leave them outside, they're fine. Bring them indoors, they go white within about 2 or 3 days. Put it outside in the acid rain again, and they're bright and shiny within a matter of a day or 2. So it's, I don't know what it is, but it's really strange.
I like the pyrite discussion, but I feel I have more problems with the marcasite than with the pyrite.
Yeah.
Marcasite decays faster than the pyrite.
That does work very, very quickly.
so there's a couple of other options. One is you don't collect sulfide minerals.
Yep.
The other
Only
thing is-
spectacular ones.
Yeah, the other thing is you don't put them in cabinets with other minerals
That's
that
quite-
might be affected.
Oh, yes.
I've
Yeah.
also been
Put
told
inside
not
a
to put them
plastic
in water.
box so they can't escape, and then you look at the end product when they've all rotted away and get some new minerals come out of it. That's quite interesting.
Well, there's also certain woods that you can't store minerals in either because of the acids in them.
Yeah.
Oak is one.
Oak is a
Well,
bad one.
I've
Oak is
had
one.
Sulfides and fluorides in the same cabinet, and it's actually etched the glass that it's sat on.
Oh, cool.
Yeah.
Yeah. You need to mask it and then do some art.
This might be nonsense, but can't you put them in the oven to dry them out?
You can,
Never
but
thought of that.
you want to remove the as much of the soluble material as possible. If you
Yeah,
just
that's
dry
what
it
I mean.
out, then the water evaporates and leaves the soluble minerals behind. Whereas if you treat it with water, with alcohol to remove the water, it takes
Yeah.
those soluble minerals out with it. So yes, putting it in the oven works fine just to dry it out.
So
Yeah.
go for
Right.
go for your dishwasher first, and then into the oven afterwards.
Yeah.
That's you all the white goods.
I
Or
have
microwave it.
How about the microwave? Yeah. How about the microwave?
And then go look
have-
for a new home.
My experience with fluorite is that it's one of the most heat sensitive crystals around. And it's very easy to make it fracture.
Yeah.
By
Yeah.
getting it unevenly heated. So I wouldn't put one in the oven. I'd be more likely to use a hair dryer or a little
Yeah. I was thinking more like pyrite nodules.
gun.
What about dehydration? You know, like some minerals dehydrate, like lomentite. Treating that or cleaning it if it's dirty, and coquimbite also tends to darken or powderize when it's exposed in the air. You know, do you have any ideas how to protect these things?
If you're in an environment that's very humid, it's gonna happen. Because some of those are hygroscopic and they just attract water. And then things like coquimbite will turn into sulfuric acid. And so your best thing to do is isolate them or seal them somehow.
Has anybody actually tried using the little silica gels? You know, in
Yeah,
the
all over the
container or
place.
something?
Yeah.
In all my cabinets.
Yeah.
So,
You know,
so yeah, you can just buy them, can't you? Like I usually just save them out of
Yeah.
shoe boxes,
Yeah.
but
Yeah.
I don't know how used up they already are. So I wouldn't mind buying fresh
One
ones.
thing that you can do, I know here in the States, I don't know about in other countries. There's actually these little canisters that you can buy for your gun safes. And those work really well. You can put them in your cabinets or whatever to try to keep them a little bit dry. And a lot of them have a stuff on top that'll go from like clear to either pink or blue or something. And when it turns that color, you can just throw it in the oven for like a couple hours.
Salt gel with an indicator.
Yep, and then turn around, put it back in again. It basically recharges it.
So all those salt gel packets and zeolites or any of those, you put them in the oven and get them above 100 Celsius, they will dry out and be reactivated again.
Yep.
And I mean, you can buy salt gel pellets in bulk if you want. I bought some zeolite in bulk. Bulk is 25 kilos at a time. I needed 100 grams. It was the cheapest way to get it. And now I've got a lifetime supply of zeolite. So
I know certain kinds of kitty litter will also work to an extent, of course.
Yeah.
And there's a product in Australia called damp sorb, which is calcium chloride, which basically absorbs water. It's like very highly hygroscopic. That would work as well, but you'd have to renew it, and I don't think I'd want liquid sloshing around in my mineral drills.
And
You can get the bags of zeolite from any aquarium place, any aquarium shop. So
I think James' question was the other way around. Minerals tend to dehydrate. And specific minerals, like a lot, do lose an hydroxide ion or a water ion. So what do we do to stop that? Because then it turns to a new mineral like torbanite, metatorbanite, things like that.
Yeah, same.
How to stop minerals from drying out? Live in Houston, Texas.
Yeah.
I have some Lake Boga salite specimens that have disintegrated over the years. So now I don't have a specimen, but I do have a lot of radioactive dust in a drawer. It's not much fun.
At least you can see it, Paul.
Especially with the UV torch.
Yeah.
Yeah, I think, Frank, just on your point, I think where you live plays a big part in that. And in some instances, you're not going to be able to do anything about it. So heliorite is an example. You know, you had a heliorite at one stage. It would have been heliorite.
Minerals change over time.
Yeah, they do. And ones like that change very rapidly. So I've got Heliorite that I collected in Tasmania that were fine and stayed blue and translucent when I lived there. But when I moved to Victoria, they changed very quickly.
Yeah,
The only
another
thing that I
bad
can
one for
suggest
that.
in that case, Frank, is actually keeping the specimen in an airtight sealed container in a inert liquid.
Yeah.
So, you know.
Yeah, another bad mineral too is chalcanthite. Is terrible.
Oh God.
To try
Yeah.
to keep
Some of them are good, some
that
of them are
intense
not.
blue color. And I got one beautiful specimen of it, and I sadly I didn't keep an eye on it, and now it has the dreaded white coating on it.
Yeah.
I hear you.
Yeah, there's not much you can do about that.
No, another one that's bad too to try to keep is hanksite from Cerros Lake, California. It's another one. It's a bugger to keep clean too. You can keep nice. And I finally ended up just taking a little rag and some mineral oil and just wiping it on it and then sealing it up in a jar.
Yeah, that's probably the only
Yeah,
way.
I just
Mine is
opened a
turned,
box of those last week and
later
found
on.
one that I hadn't coated well enough.
Mm-hmm.
Yeah, it's a steep learning curve, isn't it?
Moving on a bit, we had the conversation, well, the question from Doug in the Facebook chat as well about his needle gun, so pressure gun or whatever. Does anybody use those, or does anybody do sandblasting?
Yeah, no,
I have used them, but they're very noisy.
I've got one that I've got in the box still. I haven't actually used. It's only shoebox size, so it's a fairly small one.
Our club here in Houston has basically the dry cleaner guns is what they are, and then but then we also have an air abrasive room that has sandblasters of varying strength in it, and depending on the mineral, depending on the specimen, you can get pretty good results of it. But I've also seen some people that have gone a little too far using the abrasives as well. So it's something you got to watch.
If you're cutting your specimen in half, you're probably overdoing it.
I've used the Bosch 260 since 1991 or 2, and it's pretty. I mean, I think Dick has got the same one. I know, and I don't know. Is yours the same, Colleen?
I don't think mine's a Bosch, but it's exactly more or less the same. More or less the same.
Mine came with a needle jet and a wide jet, and I only use the needle jet on it. The spring broke once about 30 years ago, and I replaced that. That cost me about half the price of the machine. But all of a sudden, Bosch stopped doing them, and then a Korean company called Krebs took over and made some for a while. Then they vanished. But I believe that these spotting guns which I think Doug mentioned in the
he put the link on, didn't he, in the chat?
Yeah, I think David Green has used some of them, and they're quite good. But I can handhold my specimens down to a very small micro with my water gun, with my 260 water gun. If it hurts my finger, it's hurting the rock. So
yeah, it's better if you actually wear rubber gauntlets when you're.
I prefer to feel the specimen in my hand. They're all still there. So
yeah, you will actually get the water will actually force its way under the skin. So you've got it on a needle point.
I've had it for 40 years. I'm not going to last another 40 years. That ain't going to matter, I don't think.
That's a great way of removing lichen too, by the way.
Is it?
Yeah. Yeah. The thing is, it will also remove anything delicate from your specimen that you want to keep.
Yeah. So. But
that's kind of my last resort weapon of choice.
That's my go-to weapon. I've got a tray in there. I line them all up on a tray in some sort of order, so I know what I've got. Bring them in here to the sink, get the gun out, wash them all, put them in the airing cupboard, and they're dry in the evening to work on and put away. So it works quite well.
I have to use mine outside, Martin. You're obviously
using
in
the kitchen sink.
I wouldn't be allowed to do that.
Chris Marsh bought one once to try and clean some of his stuff up with, and we went around to see him, and he had like a wetsuit on. Mask.
Yeah.
What are you doing?
Safety
No, I
first.
just do mine in the kitchen sink. I know exactly where to hold it, where the pressure is, how much spray it's making, and the plants on the windowsill quite enjoy it as well. They get a water spray every so often. But no, it works for me anyway. So, and I've still got 10 of them.
Martin, I agree with you. I prefer to hold mine when I'm using the water gun, because I can tell you can even tell how much pressure you're putting on the specimen by how much it pushes back against your hand. You wouldn't get that if you have gloves on or something like that.
I disagree. But then I'm used to wearing gloves. So
yeah, but I mean, the gloves you use aren't going to stop water from hurting you, are they? The little thin things you wear.
No. You do feel it. Yeah, it'll hurt if you hit your hand. Yeah.
I mean, we did buy when I couldn't buy a replacement for my Bosch. Me and Martin bought one of these cheap Chinese ones with 25, 30 quid. Now that does hurt. The pressure on that does hurt, and I haven't quite mastered that one yet. But that's work in progress, that one. But I'll find a way around it when I have to. But at the moment, it's still going strong.
The other one that I quite get a lot of use out of is the high pressure cleaners, like your car cleaners, your car tube in Australia. They're really good for removing large amounts of mud, and I'm just going to share a picture of what the result of that is like.
Oh, that was unexpected.
They didn't get rid of the mud at all.
I just transferred the mud from the specimen somewhere else.
On to you.
So Paul, when I do the video for this, I'm going to have to put up a warning just before that photo comes up.
Use it to keep kids away from the fire.
So safety first.
Yes,
absolutely.
So, well, let's touch on that. We've been going an hour, so we might just touch on the precaution side. So, Colleen, you're a definite tick for wearing gloves at least.
Oh yeah.
Now,
and definitely goggles for that.
Definitely. And I think when I mentioned before, when I was using HCl, I was doing it outside. I wouldn't do it inside. So obviously fresh air, not a closed-in environment. What else do people tend to use or do?
Yeah, I want to just real quick.
Protective, definitely gauntlets. I wear a mask if it's really quite pungent, but definitely outside the fresh air, definitely.
Best way to use a pressure gun is let someone else do it.
I was surprised the other day. I was at our local large hardware store here, and I actually found some muriatic acid that said it was 90% less fuming. And I thought, well, I'll try it and see if it works on copper and cleaning other stuff. And I gotta admit, I never once got a whiff of the strong HCl odors from it.
Yeah.
And yet it did the job perfectly.
You can't smell carbon monoxide either, Paul.
Nor carbon dioxide.
Or carbon dioxide, yeah.
Well, and the other part of that is proper disposal of the solutions when you're done.
Very, very good point. Very good point.
Yep.
No, just throw mine on the gravel outside. That's all right. That's not a problem. I kill a few worms, but
Level up nicely.
Bicarb of soda will neutralize all acids, and you just keep dumping it in until it doesn't react anymore, and you're done.
Yeah.
Yeah,
that's what I use.
Yeah. Solvents are more difficult. Some municipalities have quite strict rules about how you're allowed to dispose of solvents.
Well, we can't buy iron out in this country, so I managed to get a hold of one from Andy Castleton who had some brought in, and I've tried it on a couple of bits of quartz and fluorite, and frankly, I'll leave my stuff with the iron on it. I can't be bothered. There's just too much messing around.
That's something we haven't really touched on, is the chelating approach to removing iron oxides and iron out and things like that. The chemistry is quite interesting. So iron out is thiosulfite, is the active ingredient, which is a reducing sulfur compound. And there's a whole, it's a bit like carbonates in the sense that there's a whole series of compounds that change the pH as you go. And the other ingredients tend to be bicarbonate, and then they tend to have a chelating agent like citric acid or tartaric acid or oxalic acid, which takes the iron that's been removed from the oxide and just keeps it in solution.
Right.
And in the link I put in, did I put the? No, I haven't put the link in. I put the link in the
you did 2
Facebook
pyrites.
chat for John Betts's cleaning things. I'll just grab it again and put it in here.
You need to understand too that all iron out is not the same.
Yes, there's quite a few combinations of compounds that will achieve the same result as iron out.
So it's Jim.
Yes. All iron outs are not the same. The super iron out is not the same chemistry as the old regular iron out, and the new spray bottle one that's supposed to non-drip is a different formula as well. I found out by going to the MS data sheets, the ones that they have for industry, and they give the actual components on those. And I've got those if anybody's interested, because they are not the same.
Yeah.
The old one is essentially Waller's solution.
Yeah.
I've just put a link in the chat to, there's a link I send people quite often whenever they ask mineral cleaning questions. John Betts Fine Minerals has a couple of articles on cleaning, and it lists Waller solution as super iron out and gives you the composition, which is quite useful.
It was also written up in the MR back years ago.
Yeah. Fun times.
All right. Anything else in terms of precautions?
I would say that if you take no other precautions, wear glasses. If there's one precaution, wear glasses.
Yeah.
You're that or a full face shield.
Yeah.
That's usually what I wear.
What Paul should have worn.
What I should have worn, yes.
Yeah.
All right. I just before we finish off, just go back to the poll. We had a second perfectionist. Does that other person want to put their hand up as well? Jim was one. Who is the other one? Not keen to actually let people know. Huh? That's all right. It's an anonymous poll anyway, so it doesn't matter. I think it's been a very good discussion. I hope everybody's got something out of it. And it'll be a useful one to go back to if people want to have a look on YouTube or whatever. And yeah, I think unless there's anything else, we might close on that. So any
just before we go, has anyone been following the Webb telescope on since that was launched at Christmas?
Funny you should say that.
Incredible photos already.
First photographs that have been published today, absolutely superb.
Yeah,
they are.
Really makes you wonder if we really truly are alone.
So
after seeing those pictures.
I like the comment in the article that I saw, which I shared with a few of the guys on the session we had about 10 or 12 hours ago or so. And that was, you could see all these galaxies throughout this photo. But the photo, if you held a grain of sand at arm's length, that was the size of the piece of sky.
Wow.
Phenomenal. Absolutely phenomenal.
That technology is just absolutely mind-blowing. It really is.
Yeah,
it is.
Right, nothing to do with cleaning minerals, of course, but
no. But,
maybe someday.
Yeah, maybe.
Well,
the mineral
that's the
furnace.
distance you want your bit of rock and when you try to get it with the water gun, you see.
Yeah, handheld grain of sand cleaning.
Yeah.
All right. I think what we might do for the next one of the suggestions was the mineral classes, and that's probably one that we can do in a number of sections. So
Yeah.
we might do elements as the first one, because generally that's the first one in sequence anyway. Maybe do that in 2 weeks' time. Does that sound like a reasonable thing to do?
Yes, sounds good.
As an interactive session?
I think we can do it partly as an interactive one. Yeah, we'll see how we progress with it. But if it generates some discussion like this one, it'll be good.
Yeah, that'd be great.
Steve,
All right.
Steve, I'll be good for the naming one.
Yes, yeah, I've got that.
After that.
So you reckon you'll be
done with it?
You reckon in 4 weeks' time be?
Yeah.
Okay, cool. So the mineral naming one that we discussed as one of the options, Jim has offered to do a presentation on that. So we'll do that in 4 weeks' time, which will be good. All right. On that note, we'll finish up for today, and everybody can either head off to bed or go clean some minerals or whatever it is that you want to do. Have a cup of coffee.
Second coffee.
Second coffee, and Paul says.
Coffee.
And Ed's having a drink as well. So, all right, and we'll see you all in 2 weeks' time.
Yeah.
Thank you very much.
Okay.
Very good.
All right.
Cheers.
Bye.
Bye.
Well,